Bayes' rule showed how evidence reshapes our beliefs. This video is about the opposite situation, when evidence changes nothing. Two events are independent if learning one tells you nothing about the other. It sounds simple, and for two events it nearly is, but independence hides some genuine surprises. It is not the same as events being incompatible. With three or more events, it splinters into pairwise and mutual versions that don't coincide. And it can appear or vanish the instant we condition on something else. We'll take these in turn: two events, then many, then independence under conditioning. Start with the definition. Two events A and B are independent when the probability of both is the product of their probabilities. PR of A and B equals PR of A times PR of B. When B has positive probability, that's the same as saying PR of A given B equals PR of A. Conditioning on B leaves A's probability untouched. The posterior equals the prior. B carries no information about A. And it's symmetric. If A is independent of B, then B is independent of A. Two dice, one red, one blue, 36 equally likely outcomes. A 4 on the red die and a 6 on the blue. The probability of both is 1/36, which is 1/6 times 1/6. The events are independent, but a 4 on the red die and a sum of 11? A red 4 makes a sum of 11 impossible. 11 needs a 5 and a 6, so the joint probability is 0, nowhere near 1/6 times the probability of the sum. The events are dependent. And beware one seductive error. Independence is not disjointness. In fact, disjoint events with positive probability are the opposite of independent. If they can't co-occur, then learning one happened tells you the other definitely did not. Their joint probability is 0, while the product of their probabilities is positive. Independence also means trials have no memory. A fair coin that just landed heads 5 times running is exactly as likely to show tails next toss as it ever was, 1/2. Believing a tail is somehow due is the gambler's fallacy. The long run balances out by swamping the past with fresh trials, never by correcting it. With more than two events, independence gets subtle. Events A1 through AN are independent only if every subset of them factors. The probability of any bunch occurring together equals the product of their individual probabilities. For three events A, B, C, that's 4 conditions: the 3 pairs and the triple all at once. Why insist on all of them? Because the pairwise conditions don't force the triple. Flip a fair coin twice. Let A be heads on the first toss, B heads on the second, and C the event that the two tosses differ. Each has probability 1/2, and any two are independent. Every pair multiplies correctly to 1/4. But all three together? A and B means 2 heads, which rules C out entirely. So the triple probability is 0, while the product of the 3 is 1/8. Pairwise independent, yet not independent. The triple condition is genuinely needed. It neither follows from the pairs nor implies them. Finally, independence can live inside a condition. Two events are conditionally independent given B if they factor under the conditional law. PR of A1 and A2 given B equals PR of A1 given B times PR of A2 given B. Because the conditional law is itself a genuine probability law, this is just ordinary independence, measured in the world where B is known. Conditioning can create independence. Toss a coin until heads is seen for the first time. Let B be the event that it took more than one toss, A1 be the event that the count is even, and A2 be the event that the count remains under 6. Unconditionally, A1 and A2 are not independent. Their joint probability is 5/16, which does not match the product of their separate probabilities. But given B, they factor cleanly. The conditional probability of A1 is 2/3. The conditional probability of A2 is 15/16. And their joint conditional probability is 5/8, exactly 2/3 times 15/16. Conditioning made them independent. Conditioning can destroy independence. A red die 2 and a blue die 6 are independent outright, 1/36. But condition on the sum being odd, 2 plus 6 is 8, which is even, so the joint conditional probability is 0, while each event alone still has conditional probability 1/6. The condition broke their independence. So independence is not one idea, but a family of them. sensitive to how many events you weigh and to what you already know. That completes conditional probability.